Let us see the example 1. A hall has 12 gates. In how many ways can a man enter the hall through one gate and come out through a different gate? So let us consider a hall. Let's take a rectangular shape. So which has 12 gates. Say G1, G2, G3, G4, G5 and G6, G7, G8, G9 and G10, G11 and G12. So total 12 gates are there. So in how many ways can a man enter the hall through one gate and come out through a different gate? So here we can see that there are two different operations. So the first operation is operation 1. So he need to enter inside the hall through any one of the gates. So he is having how many possibilities? Either he can enter through gate 1, G1, or he can G2, or he can through G4 and so on up to 12. So he can enter through any of the 12 gates. Any of the 12 gates. G1, G2 and so on up to G12. So how many ways here? 12 ways. And the next operation, and the second operation is here, and he need to come out. Now he has to come out through a different gate. He has to come out through a different gate, which means that the one gate which he has entered, he should not go from that gate again. Different gate. So suppose that, let us assume that he has entered through gate 2. Now he is inside. Now he has to exit. So he could not come out of the gate 2. So the gate 2 was closed. Now how many possibilities are there? 11 possibilities. So which means that he has to come out through a different gate can be done in 11 ways. If one gate is already selected for entering, then remaining 11 possibilities are there. 11 gates are possible for him to exit. So by fundamental principle of counting, so first he has to enter and then he has to exit, means both are like dependent. So we can say by multiplication principle, fundamental principle, by FPC, the total number of ways is nothing but total number of ways is nothing but 12 and then 11, means multiplication 12 into 11. So that is 132 ways. In 132 ways he can enter and he can exit through a different gate. Okay, right? Now let's see another example.